Matter known as ordinary, which makes up everything we know, corresponds to only 5% of the universe. Approximately half of this percentage still eluded detection. Numerical simulations made it possible to predict that the rest of this ordinary matter should be located in the large-scale structures that form the cosmic web at temperatures between 100,000 and 10 million degrees. A team led by a researcher from the University of Geneva, UNIG, Switzerland, observed this phenomenon directly. The research shows that the majority of the missing ordinary matter is found in the form of a very hot gas associated with intergalactic filaments. Galaxies are formed when ordinary matter collapses then cools down. In order to understand the origin of this formation, it was vital to discover in what form and where the ordinary matter that we do not perceive known as the missing baryons is found. To do this, the astrophysicists from UNIG and the École Polytechnique Fédérale de Lausanne, EPFL, took an interest in a Belle 2744, a massive cluster of galaxies with a complex distribution of dark and luminous matter at its center. They observed this cluster with the XMM space telescope, which is capable of detecting the signature of very hot gas due to its sensitivity to X-rays. Large-scale galaxy surveys have shown that the distribution of ordinary matter in the universe is not homogeneous. Instead, under the action of gravity, matter is concentrated into filamentary structures, forming a network of knots and links called the cosmic web. The regions experiencing the highest gravitational force collapse and form the knots of the network, such as a Belle 2744. Comparable to neural networks, these knots then connect to one another through filaments, wherein the researchers identified the presence of gas, and consequently, the missing baryons. The astrophysicists pointed XMM in the direction of the areas where they suspected to find the presence of filaments, and therefore, the presence of 10 million degree hot gas structures. For the first time, they were able to measure the temperature and density of these objects, and found that they corresponded to the predictions of the numerical models. For this reason, we now have a grasp of the form taken by the missing ordinary matter.